This is Unit 7, Physical Behavior of Matter. Lesson 3, Phase Changes in Heat. How does energy impact the phase changes of substances? The objectives of this lesson: I can identify if a substance is a solid, liquid, or a gas. I can determine if a phase change is endothermic or exothermic, and I can differentiate between potential and kinetic energy changes on a phase change diagram. So do now. Solids, as we recall, so we've talked about this a little more, but here it is in review again. Solids have a definite shape, they have a definite volume, they have constant vibration, and the molecules are packed tightly in a geometric or crystalline pattern. So we've seen this before, and as we talked about in our bonding unit, their intermolecular forces are strong. Liquids have no definite shape. They take the shape of the container, but they have a definite volume, which means they do not fill the container. So if I were to remove a sample of liquid from my so if I were to remove some liquid from my sample, it would not fill the rest of that volume. And that's something that we've talked about before, and I want you to continue to remember that. Liquids are in constant motion, however, they like flow over each other. Flow is a good way to describe their motion. They have no arrangement. The molecules are further apart than solids, but closer together than a gas, and their intermolecular forces are moderate or medium, in between. Gases have no definite volume. They fill the container, and no definite shape. They take the shape of the container. They have constant motion. They have the most amount of movement. And they have no arrangement. They're not in any organization. The molecules are very far apart, and their intermolecular forces are weak. So I believe I gave you a chart in your notes, so you can just kind of summarize in that chart all of these different things, so you don't have to write every single word. Phase changes, most of these you're familiar with, but two new ones. Sublimation. Sublimation is going directly from a solid to a gas. And deposition. A deposition is going directly from a gas to a solid. The rest of these you should be familiar with. Freezing, if I'm going from liquid to a solid. Melting, going from a solid to a liquid. Evaporation, going from a liquid to a gas. And condensation, going from a gas to a liquid. So phase changes that are endothermic, so ones that absorb energy. If I'm absorbing energy, that means heat is going into it. Absorb, or into, or endo. That's how I remember those things. Solid plus heat is going to produce liquids. That's melting. Liquid plus heat is going to produce a gas, vaporization or boiling. And solid plus heat going directly to a gas, sublimation. All those absorb heat. Basically, I'm thinking if they're going from left to right. So if I'm going from a solid to a liquid, or a liquid to a gas, or a solid to a gas, going from right to left on this diagram. The phase changes that are exothermic, where energy is being released, released, or exiting. When heat is being released, I'm going from a liquid to a solid, going from a gas to a liquid, and going from a gas to a solid. Heat is then as a product being released. Freezing, condensing, and deposition. So I think going from right to left on this diagram. Thermochemistry is the study of energy changes that occur in a chemical reaction. So this half of our unit is about heat, if you notice. So we're doing thermochemistry. The kinetic energy refers to the energy of motion, again, motion, also known as the temperature, the average kinetic energy. Potential energy refers to stored energy, such as in chemical bonds. So this is a phase change diagram, and you will probably see this. You'll see this on the test for sure, and most regions talk about this in some way or another. So the way the phase change diagram goes, this is what we call a heating curve, because I am putting heat into it. So energy is being absorbed. So it is, this is an endothermic heating curve. I start down here at the bottom. So as I add constant heat across the top, across the x-axis. The y-axis is our measure of average kinetic energy, or our temperature. So as I add heat, I am at a solid phase until I reach this point right here. And that is going to be the melting point. On my straight line here, I have an equilibrium between a solid and a liquid. So I like what this shows. My solid is coming apart and becoming liquid, so I have a mix of both. This is my freezing point if I'm coming down, and my melting as I go up. At this point, when I have a phase change, there is no temperature change. Then, once all my solid is melted, I'm completely in my liquid phase. I continue adding heat, and I'm all liquid until I reach this point, which is my boiling point. So, as I'm boiling, my liquid is becoming a gas, and I have an equilibrium between gas and liquid until all of my liquid is boiled, and now I'm at a solid gas here. And as you notice, whenever I have a phase change, there are no temperature changes. And when I'm in a phase, liquid, solid, or gas, I have temperature changes. So here is that again in a different format. If I have just water, water, when it's solid is ice. Ice and water is right here at zero. So you know that's where water freezes. So the freezing point or the melting point, it's the same thing, the same temperature. I have an equal mix, or I have a mix of ice and water. When I have just water, I can change that temperature up until I reach the boiling point, which is 100 degrees Celsius. This is also the condensation point. It's the same temperature, where I have a mix of water and steam. Once all the water has evaporated or boiled, I have just steam or gas phase, and then that temperature will increase. So check your understanding. Okay, so now you can identify if a substance is a solid, liquid, or gas. You can determine if a phase change is endothermic or exothermic, and you can differentiate between potential and kinetic energy changes on a phase change diagram. So this is a super important diagram that you should be able to read.